MS Ramaiah University of Applied Sciences.
Hi students, let us discuss the calibration of linear variable differential transformer LVDT. This experiment aims at studying the characteristics of linear variable differential transformer and calibration of the instrument. Calibration is necessary for verifying the correctness of a reading as obtained by a measuring instrument. Comparison between a known measurement, which is a standard, and the measurement as obtained by a measuring instrument. It is carried out for a new instrument, a repaired or a modified instrument, after the lapse of a specific time period, after a specific number of hours of usage of an instrument, and in other similar scenarios. The cross-sectional view of LVDT setup represents the one primary winding and two secondary windings with iron core. It is covered by high permeability magnetic shell, high density glass-filled polymer coil form, epoxy encapsulation, and stainless steel housing with end caps. LVDT is constructed by aluminium housing, soft iron core, displacement indicator, screw gauge, primary coil at the center and secondary coils at the sides. The accuracy of LVDT setup gives plus or minus 10 mm and least count of screw gauge is 0.01 mm. During experiment by the application of force, that is displacement, if iron core remains in the null position without any movement, it indicates that voltage induced in the secondary coils are equal and results in net output will be equal to 0. If iron core tends to move to the left hand side, that indicates electromotive force, that is EMF, induced in the first secondary coil is greater than the EMF induced in second secondary coil. If the iron core tends to move to the right hand side, that indicates electromotive force induced in the second secondary coil is greater than the EMF induced in first secondary coil. LVDT acts as a transducer and the displacement, which is a non-electrical, that is mechanical energy, is converted into an electrical energy. It works under the principle of mutual inductance. Mutual inductance is an effect which occurs as soon as an electromotive force is produced in a coil due to change in current in a combined coil. LVDT setup will be used to measure the displacement from fraction millimeter to centimeter. The apparatus required to conduct the load cell experiment are LVDT setup, screw gauge, primary coil, secondary coils, and displacement indicator. The procedure for carrying out this experiment is as follows. Switch on the LVDT setup unit from main power supply. As display is calibrated, movement of LVDT shaft from 0 is displayed in millimeter by rotating the screw gauge. Screw gauge is set to 0. Using tare knob, set the indicator to 0. Now, move the LVDT shaft to some particular value in the micrometer and set the same in indicator using the span knob. Now note down the indicator and micrometer reading by rotating the screw gauge. The readings obtained from the experiment must be tabulated in the format of a tabular column. Carry out the calculations using the standard formulae of reading a load cell and find the error in reading as well as the sensitivity value of the instrument. One graph to be plotted after tabulating the readings in the tabular column, indicating the indicated reading versus screw gauge readings of LVDT setup. This experiment has its own benefits and limitations. Benefits of the experiment. Very good linearity and high sensitivity measurements can be obtained. LVDT provides less friction and low power consumption while operation. Limitations of the experiment. It is sensitive to temperature measurements and it leads to variation in readings.
Hi students, name of the experiment is linear variable differential transformer. Aim of the experiment is we are going to study the characteristics of linear variable differential transformer. We will call it as LVDT. So calibration of LVDT setup consists of the mains on, switch on the main power supply, so that indicates that mains on is switched on. So it is showing in red color. Console on. The console on indicates that whether machine is in running condition or not. Once you switch off the console on, you can able to see the displacement indicator. Displacement indicator. So it is when you switch on that, you can able to see the displacement indicator. Tare knob, span knob. The tare knob will be used to set initially the equipment you are going to set according to the screw gauge reading. The span knob is you are going to use 0 value to set 0 value with respect to the reference displacement in the screw gauge. And this is the LVDT setup. So the LVDT setup consists of one primary winding. It is located in the middle of this setup, and two secondary windings is placed in the other side of the primary winding. And these two secondary windings placed in opposite to each other, winded in opposite to each other to get the net voltage of the LVDT setup. And this is the iron core. The iron core, when you apply the force on this particular iron core, you can able to see the displacement value in the displacement indicator. And screw gauge. The screw gauge, here we are going to apply the force on the screw gauge. So that is going to transform into the LVDT setup to get the displacement value from the displacement indicator of the LVDT setup. Let us start the experiments now. Now I am going to apply the force on the screw gauge. So before applying the force on the screw gauge, I am going to set the screw gauge value to 0. Then according to the screw gauge value, I need to set displacement indicator value by using tare knob. Now I am going to set 0 value in the screw gauge. Now I set a 0 value in the screw gauge, you can see here. Now I am going to lock this by using locking option from the screw gauge. Now according to the screw gauge value, so I need to set the displacement indicator should be same value. So I am going to use the tare knob to set the same value in the displacement indicator. Now I set 0 value by using tare knob in the displacement indicator. Now I am going to give a small movement to the LVDT setup by using a screw gauge. So I am going to give a movement of 5 mm. By using screw gauge, and parallelly you can observe the LVDT reading. Displacement reading. So now I given a 5 mm displacement in the LVDT setup, and you can observe the displacement indicator in the displacement indicator is going to show the same value. So if anything is problem with means we are not getting the same value, anyway it is same now. can use the span knob to adjust the same value with respect to the screw gauge reading. Once you set this, this is the reference point for your further readings. So from here I am going to give a displacement again for a 5 mm. Now given 5 mm displacement in the screw gauge reading and LVDT cell setup, and you can see what is the value you are getting from the displacement indicator. It is 9.97. So approximately there is 0.03 mm is an error we can get from the LVDT setup. Now similarly you can use different readings, give a different displacement reading in the screw gauge, and you can note down the displacement reading from the LVDT setup. So it concludes the LVDT experiment.
At MSR UAS, we spark your imagination unlike any other.